Hi all. Today we're going to continue the differential equation. Okay. So the first one is partial differential equation. Let's see that. Equation involves more than one independent variable. We know that partial differential equation will be like dou by dou x or dou by dou y or dou square by dou x square. So it will be like dou. Okay. So dou means partial. So equation involves more than one independent variables. So this equation may contain x, y, z, anything. So we're gonna use the dou here. Okay. The order of partial differential equation will be the highest derivative. We know that order means highest derivative. Okay. In this thing, what is the order means? The order is 2. This is the highest derivative. Degree means highest derivative's power is what? 1. So degree is 1. Okay. And as I told you, the notations will be dou by dou. Okay, you can see here. Here, dou z by dou x, which is equal to p. Like, if z is a function, I am partial differentiating this z with respect to x and with respect to y, with respect to x square, xy, y square. Okay, so dou z by dou x, which is equal to p. If this z is with respect to x, means it will be p. So we can say this p as zx because z with respect to x. The same here, z, dou z with respect to dou y. So zy, this is q. And this is the first derivative, right? First derivative with respect to x. If we differentiate, like if we partial differentiate this one, again means it will become dou square z by dou x square. Like it here you can see this is zx. Then if we differentiate it again means it will become zxx, right? And again dou square z by dou x dou y. So first with respect to x and then with respect to y. So zxy, or you can say zy, like zyx. If it is zyx means it will be dou square z by dou y dou x. So first with respect to y and then with respect to x. These terms are called s. Just these are the notations. Okay. Dou square z by dou y square. So this term again we need to differentiate it with respect to y, means we will get the t value. Zyy. How to form this partial differential equation? Just we need to eliminate the arbitrary constants, like if they have given or not or a, b, c as a constants in this equation, means we need to eliminate these terms. Then we will get the partial differential equation. So first one is what means, if this equation, if some equation contains n number of arbitrary constants or n independent variables, means this equation will give first order partial differential equation. What is first order? Like only the first derivative. Okay, so if the equation contains many n number of constants and n number of variables, so ஒரு equationல n number of constants and n number of variables இருக்கிறப்ப it will give only first derivative. So first order partial differential equation மட்டும்தான் கிடைக்கும். Second one, if the equation contains n arbitrary functions, here we have seen constants and variables. Here arbitrary functions means, if it is functions means it will give nth order. Okay, number of arbitrary constants always greater than number of independent variables. So how many numbers, எவ்வளோ numbers of arbitrary constants இருக்கோ அது வந்து எப்போவுமே அதிகமாக இருக்கும் எதை விடனா number of independent variables. So just we are comparing the two things, like three things here: constants, variables and order. Okay, here the function and order, and then constants and variables. Okay, so இந்த மாதிரி அதிகமாக இருக்கும்போது number of arbitrary constants is greater than number of independent variables means it will give higher order partial differential equation. Okay, let's see some sums. PDE, partial differential equation. So they have given one term here. So first what we need to do means we need to find A and B because these are the constants. So we need to remove these things. Then we will get the partial differential equation. How can I do this means I first need to differentiate it with respect to x and y. That's it. So if I differentiate with respect to x means I will get 2 into, if we differentiate z means it will become dou z by dou x. Why I have used dou means here there are two variables. I need to I need to differentiate with respect to x and y. So அங்க ரெண்டு வேரியபிள்ஸ் இருக்கு. ஸோ ரெண்டு வேரியபிள்ஸையும் நம்ம டிஃப்ரென்ஷியேட் பண்ணணும். ஸோ அதனால் this is partial differentiation. So we're gonna use dou. 2 into dou z by dou x. 2 into, if we differentiate z, it will become dou z by dou x, which is equal to, here you can see here there are two terms. This one is constant. If it is with respect to x means, so I'm just gonna consider this term like 2x by a square. Okay, power முன்னாடி கொண்டு வந்து பவரில் ஒன்று மைனஸ் பண்ணும். So 2x, that's it. The same applies here. So just replace the y, x with respect to y. Okay, just replace x with y. You will get this answer. We know that dou z by dou x is nothing but zx, which is equal to p, right? This term is p and this term is q. So I have got p which is equal to this term and q which is equal to this term, right? So I have wrote these things in terms of p and q. After that I need to substitute these things here. Like you know, in questions 2z which is equal to, I'm just writing x into x by a square. So this part plus y into y by b square. So this part. So these two parts I'm gonna replace it by pq. So 2z which is equal to p into x plus q into y. You can see here. So this is the thing here. After that, what is p? Dou z by dou x. With respect to x means it will be p. With respect to y means it will be q. So this is the answer. Okay. So whatever the thing, just we need to replace this a, b here and you will get the answer. If you want to replace this constants, just use p and q. Okay. Yes. And the next thing, partial differential equation, they have given one function z which is equal to f of function plus g of one function. So what I need to do is, first I need to take with respect to x and then with respect to y, right? This is common. So with respect to x means it will be p. With respect to y it will be q, right? So you can see here, if I need to differentiate these two terms with respect to x means, here you can see only x is here. This y term will become constant. So this will be 0. These two things, if you differentiate x, you will get only 1, right? So if I differentiate this thing means I will not get, like this is f of function. So if I differentiate it means it will give f dash of function plus g dash of function. But here again we need to differentiate the function also. But here if with respect to x means, you can see here, if I differentiate x it will become 1. So into 1. Again here into 1. So this is over. and here with respect to y, y means there is a constant with y. So f dash of the function into a, because if you differentiate this term you will get a. Again here also an a, like minus a, here there is a minus. So again if I differentiate, I need to find the r and t term, not s. Okay, r and t term. R means again we need to differentiate p with respect to x. The same here. So second derivative, if I do so, I will get f double dash of the function plus g double dash of the function. So this is over, and you can see here f double dash of the function into, there is already an a here. Again if I differentiate, it means I will get another a, right? So a square plus g double dash of, already there is minus a here. Again if I differentiate this term, it will bring me a again. So it will become a square. Okay, you can see here this is same as here, just we need to take the a square outside. So t, which is equal to a square into r. If I take a outside means I will get the r here. Okay, so we don't need to do anything, just substitute all the values for t and r. Okay, you will get the function. So this is in the function, so we just differentiate this function to a partial differentiation. Partial means dou, that's it. Okay, yes. Let's see another thing, solving PDE, partial differential equation. So how can we do that? First we are going to see the first order linear partial differential equation, that is first order, first derivative, which is nothing but Lagrange's linear equation. Okay, what is Lagrange's linear equation means? You can see here capital P into P plus, means this is rho. Okay, capital P into rho plus Q into small q, which is equal to R. Here P and Q are the functions of x or y or z. Yes, yes. So P plus Q, which is equal to R. P into rho, one constant, like one thing, plus Q into Q, small q, which is equal to R. This equation is also called quasi-linear equation, quasi. Okay, so this is the thing. Let's see that when P, Q, R are independent of Z, means if these three things, these three functions are independent of Z, means what? It may be x and y functions, not Z. So it is independent of Z, means then this equation is said to be the linear equation. Okay, to solve the equation, form the subsidiary equations. So we need to form the subsidiary equation like dx by p, dy by q, dz by z. So I am just going to form, you know here three functions, p, q, r. These are the three functions. So I am just taking these three functions in the denominator, and then I am just giving dx, dy and dz. So I am just forming this as a subsidiary equation. So first we need to form the subsidiary equation. Solve the simultaneous equation which gives u equal to a and v equal to b. So if we solve this, we will get u of some function which is equal to a and v of which is equal to b as solutions. Okay, at last the complete solution will be like pi of u comma v, the whole function which is equal to 0, or we can write u which is equal to the function of v. So at last we can write like this. Let's see that in the sum. Solve, they have given one question and they have given like this term is what? P into rho plus this term is q, capital Q into small q, which is equal to this term is r. So we know that PQR is what? So I am just taking dx by P minus dy by Q, which is equal to dy by q, which is equal to dz by r. But here one thing you can see here, I am just modifying this equation, like there is a x in the denominator, just took all these, just multiply all this, all the term by x, so we can get this term. So this one is p and this one is q and this one is on, as you know I have written this. So I am just solving first two equation. Why I have took first two equation means there is z is common, right? So I am just taking first two equations. I am just rewriting it. This one into x square and this one into y square. I am just rewriting it. After that z will get cancelled. If we differentiate it, like you need to integrate it. Whatever may be the function with dx means you start to integrate it and put plus c here. Okay. If you do so, you will get x cube by 3 which is equal to y cube by 3 plus c. Because power la one add panni same power la divide pannu. So this is the thing. After that, just write it as in a form which is equal to a. Why I have wrote like this means, you can see here x cube minus y cube which is equal to 3c. This may be the thing. So I am just taking 3c as a. So I am just writing a. You can see here this is like u which is equal to a form. Like u, the one form here, and then a is another side. The same appears here. But here I'm just taking 1 and third equation because y square is common. I'm taking so, and I'm just taking integration here plus c, and you know after that I finally got v equal to b, the function, like x square minus z square which is equal to b. So from these two functions I have got a and b, right? So what is the thing at last means, at last I need to write it as pi of u comma v which is equal to 0, or else u which is equal to f of function. So I am just taking u which is equal to f of function. What is u here? We know that u is equal to a. So this term is u. So u which is equal to f of v function. So we have got the equation. Okay. Yes. So let's see the next thing. Non-linear first order equation. Before that we have seen only the linear. So here comes the non-linear. The equation should has PQ other than first degree. So the equation should always have P and Q considering other than first degree. There are 4 standard forms of these equations. So non-linear equation, they have 4 forms. Let's see that. The first form is what? F of rho comma q which is equal to 0. So the complete solution will be like z equal to x plus by plus c. Okay. So the complete solution will be like this one, where a and b are connected by the function like f of a comma b. So you can see here initially the function is like rho comma q, right? So I am just rewriting it as f of a comma b. What is the meaning? We need to replace this rho q as ab, right? Yes. So after that, this equation, by solving this equation, you will get b which is equal to the function of a. So just take this as z and substitute here in the whole equation. Okay. Sorry. So just from this equation you will get b which is equal to function of a. Up to this is okay. So I am just substituting this value in z equation and you will get the answer here. Also you can easily remove the AC. If you see that these things in the sum means it will be easy. As you see, they have given one problem here. Means this is rho. Okay. Okay. Root of rho plus root of q which is equal to 1. This is in the form of PQ which is equal to 0 means I need to put this term as 0, right? I am just bringing this one here. So I just made this as 0. Next thing is what? I need to replace it to AB. So I'm just replacing rho as A and Q as B. Okay. So I'm just replacing it. As you know, I need to write it as B, which is equal to function of A. So I'm taking B here. So I just found B. This is like as a function of A. Just substitute this B in the A Z equation. Z is what? Ax plus by plus c. I'm just substituting this b term here. So I will get the solution. That's it. So it's dead easy. Replace AB and found B and substitute in Z. So replace AB, found B, substitute in Z. This is the first form. Next, the second form. It contains an extra value Z, f of Z comma P comma Q, which is equal to 0. Then what we will do? First thing is we need to assume this equation like u which is equal to x plus ay. Just assume this equation. After that, we need to substitute these two things like rho which is equal to dou z by dou u and q which is equal to a into dou z by dou u. So these two things. Solve the resulting ordinary differential equation in z and u. And the coming equation, resulting equation will be z and u. You need to replace u by the original term like u which is equal to x plus ay, right? So original term. We'll see that in sum. P of rho of 1 plus q which is equal to qz. So you can see here the rho is what? Tz by du. Again q is what? Tz by du into a. So these are the two things. I am just substituting these two values in the original equation. So the original equation will become like rho is what? Dou z by dou u into 1 plus q is what? A into this term which is equal to q a into this term into z. So I am just writing this z in the center. Is it okay? Yes. And we know u which is equal to x plus ay. This is an equation. Okay. So you can see here I am just taking this u du as a separate term because you can see here u which is equal to the whole term. So I am just taking this du in one side like first the plus 1 will go there as minus 1 and du dz by du will get cancelled and the remaining term I am just solving it. You can see here. So by taking the integration I will get this form. So log of the base k because f of x which is in integration f of x which f dash of x. So f dash of x by f of x into if this is an integration means if these things in integration means the answer will be log of f of x. Okay, so by substituting all these things you will get the value. At last you need to substitute the u value. That's it. Okay, and the third form, the equation will be like f of function which is equal to g of function. The inside the function you can see here x rho y q. So we need to separate x rho and y q. Okay, so first thing is what means we need to assume this two functions as a. By taking separately you can easily solve the rho and q will be in the function x function and y function. Okay, so we can write this dz like if it is dz means we can write this as just concentrate dou z by a term, right? So I am just writing dou z into dx plus dou z into dy. Here dou x and dou y. So this is a term. You can see here alternatively there comes only d, and in the middle there comes only dou. So this is this function. Okay, so we know that dou z by dou x is what? P and Q. So I just wrote these things. And after that you can see here P is what? A function of x. Q is what? A function of y. So I'm just replacing these things and I'm taking integration. Then you will get the value. Okay, just see in sum you will get a clear idea here. Rho square plus q square, which is equal to x plus y. This is a question. What I need to do? I'm just separating x and rho, y and q. So as you know, I'm just separating p, rho and x, q and y. I done that. After that I am just taking this function as a. So this term will be equal to a and this term will be equal to a. From this I just found a and q. Here there is q square, right? Sorry, q. So I have found rho and q. So what is the thing is, you can see here we can write this dz as rho into dx plus q into dy, right? So in this part I am just substituting these two equations. After that I need to take the integration. You can see here in case of integration, if I want to integrate x square means it will become x cube by 3, right? So power la one add panni same power la divide pannu. Yes, but if this action is some addition or some subtraction with some other variables means just simply add 1 plus 1 to the power. So 3 by 2 by 3 by 2. Same applies here. Plus b. If they have given 2x means into 2. 2y means into 2. That's the thing here. So after rearranging all these things, you will get the answer. Okay. And the last one, form 4. The equation will be like px rho x plus qy plus f of rho q. So the both function. Just replace rho q as AB. So we need to replace this rho q as AB. So complete the solution. After that we will get the complete solution here. So I am just giving some one function here. You can see here what is the thing, the fourth form. If they have given rho and q means just substitute it as AB. That's it. So next we are gonna see the higher order partial differential equation. What is this higher order? Higher order means up to nth. We know that. So we can see that homogeneous linear equation with constant coefficient means we need to add k, right? Because this is constant. So rho par n is by dou par n is by dou x par n. So we have seen this equation, the homogeneous, n minus 1, k1 into n minus 1, kn into n. If it is k2 means k2 into dou par n minus 2. So the same things appears here. You can see k1, k2 up to kn, these things are constants. Here this equation is homogeneous. Okay, so homogeneous means what? All derivatives in this equation will contain the same order. So the derivatives always have the same order. You can see here the order is 1, the order is 1, the order is 1. So it has only same orders, means it will be homogeneous equation. Okay, the next thing is here in this term, like in higher order homogeneous linear equation with constant coefficients, we will denote this dou z by dou x as d and then dou z by dou y as d dash. Okay, this is the thing, dou z by dou x as d and dou z by dou y as d dash. Okay, so if I replace these two things here means I will get the equation as d power n plus k1 into d power n minus 1 into d dash up to this term into z, because we are saying only these things. So I am just taking the z as outside. Okay. So this equation will be like f of d dash into z, which is equal to the capital F of one function. Okay. So capital F of one functions. So as you know, this z has two parts of answers, like complementary function and particular integral, right? So there are some rules. This is dead easy actually. Rules for complementary function, which is nothing but we need to take the left hand side, which is equal to 0, right? So here I just gonna replace d by lambda and I am just taking d dash as 1. This is the thing. Okay. So we gonna replace d by lambda and d dash as 1. Then we will get some lambda which is equal to 0, like this function. So this function is nothing but auxiliary equation. So depending on the roots, we will get some roots for the lambda values. So depending on the roots, we will write the function. In the previous term, we will write c1 into e power, c2 into e power likewise. But here we need to write as whole function. Okay, yes. So function means what? Y plus m1 into x, y plus m2 into x. So function 1 of, function 2 of, like that we gonna do. If it is repeated means just write f1 into the function y plus mx plus just add x into f2 of this function. Again, if it is if it is repeating, like 3 times it is repeating, means f1, f2, f3. So here the second term will contain x, third term will contain x square. That's it. It will go on. So let's see some sums. You will get a clear idea. So they have given one function here, and we know that dou z by dou x, I am gonna replace it by d, and dou z by dou y means I gonna replace it by d dash, right? Here dou square z by dou x square means d square, this term square, which is equal to d square. Again here d dash square means d dash square. Here you can see here first is x and second with respect to y. So d and d is for with respect to x, d dash is for y. So I am just taking d and d dash. So this is the equation. Next thing is what? I am just gonna replace d as lambda and d dash as 1. So just replace these things. Lambda square minus 3 lambda, this will become 1 plus 2 into 1. I will get the value as lambda. So just substitute in the equation, like f1 of the function, f2 of the function, y plus 2x, y plus x. So this is the thing. And here comes the next question. This is like d square, d dash square. I'm just replacing it with lambda. I have got plus or minus a. Yes, just substitute here in the function. So next thing is, there are some rules for particular integral. Let's see that. Particular integral means what? We need to, like the function is like f of d dash into z, which is equal to f of x y, right? This is the function as you've seen that, the coefficient function. Here just omit this z and take this part as inverse 1 by the function into this x part, f of xy. This is the particular integral. Okay, after this thing, this function, so depending on this f of function, we have got some cases here. We will see that if this f of function is like e power value, e power ax plus by means, just we need to replace d as a and d dash as b. So just remember that d as a and d dash as b. Okay, yes. After that, After that, so this is the first case. Second case is what? If f of function will be equal to sine or cos, like mx plus ny means you need to replace it by, this is what? D. This is what? D dash. So D as m and D dash as n. You can see here D square. If there's D means we need to put m. So D square, which is equal to minus m square. D dash means minus. You need to put minus in all the term. D dash means mn. D dash square means n square. So just think that D with respect to n and D dash as n. Just put minus in all terms. You will get the answer. And the third case, f of xy, the function is like x power m, y power n. If it is like in the power means expand it the powers in the ascending order, then you will get the operation. Okay. And the fourth case is what? If any function of x or y, just write it as this thing and resolve the denominator, this term. Just resolve it and you will get the answer. How can I resolve it means? You can easily write this operation as 1 by d minus m into d dash. 1 by d minus m into d dash. Okay. Normally we write the auxiliary equation, means auxiliary equation like x square plus 4x plus 4 means you can write this as x minus 2, like 4, 2, 2. If we add this means it will get, okay, x plus 2, x plus 2. Right. So likewise here we are writing d plus, okay, d minus m d dash. This is like x minus 2, right? If we write like this means m is what? The roots. So instead of x I am just putting d minus m d dash. You need to operate like this and you will get to solve this. Okay. After that, replace that y, okay, this y function as c minus mx. By doing so, you can get the function. You will see the last fourth option here. Okay, as a sum. They have given one function which is equal to 16 log x plus 2y. And here I am just replacing d by what? Lambda. D dash by 1. So after replacing it, I just got the value as lambda, which is equal to 1 by 2, 1 by 2. So I know Ci, which is equal to the function of f1 function plus these are repeated, right? So f1 into function plus x into f2 of function. So I am just writing it as particular integral, like I am just doing this equation in downward, which is equal to the left hand side. So I have wrote that like here the whole function into z. Okay. So this is finished. After that, so here this is in the form a square minus 2ab plus b square, right? So you can see here I am just taking this 4 outside, means this term, this equation will become like d square minus d dash plus 1 by 4 into d dash square. So here a is what? Only d. Here b is what? 1 by 2 d, right? Yes. So a is what? This is a and b is 1 by 2 d. Okay. So the thing is here a minus b. Okay. A square minus 2ab plus b square, which is equal to what? A minus b the whole square. So here the whole square. Okay, this is the thing. After that, I just took 4 outside, right? So I am just cancelling. This 4 is its denominator. So if we cancel this 4, this 16 means it will become 4, right? So I am just writing it here. And then the function, which is equal to, I am just replacing y term alone. Okay, after that you can see here inside, like here what is the thing, 2 into c minus mx, right? So I'm just writing 2c minus 2mx, 2c minus 2mx. M is what? M is nothing but 1 by 2. So I'm just writing here. As you can see here, this 2 will get cancelled, and this x will get cancelled because it is plus and minus. So only thing remaining is 2c into this one is what? Dx. Here log 2c is constant value. Log 2c is constant value. So this will be like log 2c integral of dx. So I will get only x. Okay? Yes. So after that, just 4 into the term which is equal to, I am just taking this c again, as we know that y which is equal to c minus mx. So c is what? Y plus mx. M is half. So y plus mx. I am just taking again, replacing it. After that, so this whole term I am just writing it as integral. So integral of x into this term into dx. Okay? Yes. After that I am just integrating this term like x square by 2, x square by 2. Okay? Yes. Into log of some function, log 2c. This is log 2c. Okay? How log 2c means? Here you can see here, after replacing y as like c, okay, replacing c which is equal to y plus mx. So y plus mx. Again I am replacing this y, c minus mx. So c minus m is what? Half x. So you can see here these two things will get cancelled and only c will come. So by doing so you will easily get the value. So c is what? Again replace it. C is what? Y plus mx. So y plus mx. Here is half. So if you multiply this 2 inside means you will get this value. So this is a value. Okay. Next thing is what? Classification of partial differential equation. So just take like a into dou square z by dou x square plus b into dou square z by dou x dou y. So a square, ab, b square will be like this. So a into the term, b into the term, c into the term plus some functions. The function may contain x, y, z, rho, q, which is equal to 0 means we can directly write this as, okay, actually we see some formula minus b plus or minus square root of b square minus 4ac, right, by 2a. This is for complex roots. So just took this part alone, inside it, not the square root, inside part alone, b square minus 4ac. Likewise b square minus 4ac, if it is less than 0 means it is elliptical. If it is equal to 0 means it is parabola. If it is greater than 0 means hyperbola. Where can I get a, b, c values? From the equations. The coefficient of d square z by dx square means it is a. Sorry, dou square z by dou x square means it is a. Dou square z by dou x dou y, it is b, and it is c. So likewise you can get the values here and substitute it. You will easily get the, means you can easily say what is the equation is. Okay, so like let's see some example here. They have given one function. You can see here dou square, this is dou square, sorry, dou square z by dou x square, dou square z by dou y square. You can easily see this one is what? A, and this term is what? B, right? Sorry, this term is C, right? Yes. So here B is what? B is nothing but B is 0. There is no B. So they have given one functions here. So which says, as you know, as I said, A is x square, C is 1 minus y square, and B is 0. So after that, just substitute b square minus 4ac. By substituting, there is a negative part here, minus 4x square, right, into a term here. This is like y square. So if you this term and this term, it is in multiplication. So by substituting any values for x and y, you will get only the negative values. So which is less than 0. So you can easily say it is an elliptical form. Let's see another sum. Here r is what? We know that r is what? Dou square z by dou x square, right, with respect to x. Here the same, dou square z by dou y square. Here the s is what? Dou square z by first term dou or dou y. It can be anything. So the s will be this, like this. So we just need to take the coefficient this thing as a and b and c. By substituting, so you will get which is greater than 0. All are in additions, so it definitely will be greater than 0. So hyperbola. So they have given another sum here. So a is what? 1, 4, 4. By doing so, this is equal to 0. So that is, this equation is related to parabola. Okay, let's see another sum here. They have given one equation PDE, partial differential equation, you can see here, which is equal to 0. I need to find the degree and order. As you know, the highest, what is order? The highest derivative is what? Second derivative. So 2 is the order. Second derivative, 2 is the order. In the second derivative, what is the power? 1 is the power. So 1 is degree, right? That's it. So next sum is, they have given one partial differential equation here, and we need to identify which equation it is. You can see here they have given one equation. This is like first derivatives, and then it will give second derivatives. But if I say a linear equation will be like y double dash. So first three derivatives means plus 3 into y double dash plus 2 into y dash plus 1 into y, which is equal to 0. So the partial, which is equal to x term, sorry. So the linear equation will be like this. But here you can see this is first derivative, this is first derivative, and suddenly there come the second derivative. Okay, there is no order in it. So this equation is non-linear equation. We know that non-linear equation. We have found this. And here the highest order is what? 2. So it is a second order non-linear equation. Okay. Okay. Let's see Laplace transform and application here. This is somewhat important. Okay. Let's see that f of t is a function. Okay, f of t is a function. So this function here, the t will have all the values greater than 0. Okay, yes. So I can say the Laplace transform of f of t will be denoted by L of f of t or f bar of s or capital F of s. So you can denote it like this, as in the left hand sides, which is equal to, this is the equation. You can see here, f of function of t into e power st into dt. The limit will be 0 to infinity. So this is the function here. So here s is a parameter which have real and complex numbers only. It may contain I and real numbers like 2, 3, 4. So it should have only the real and complex numbers. So f of function into e power st into dt. This is nothing but Laplace transform. So we need to find Laplace transform. They have given one function here, f of t, which is equal to 1. T is what? Which is greater than or equal to 0. What is the formula? F of t into e power st. they have given this term as 1. So this term will become 1. So it will become 1. And considering this term, I am just integrating it e power minus st by minus s. So the limit is what? 0 to infinity. E power minus infinity is 0. We know that. So the first term will get 0. And if we substitute this term means upper limit minus of lower limit, right? So here if we substitute 0 here means it will become 1. But here minus, because we are substituting lower limit. So this minus will get cancelled. 1 by s will be here. So this is the answer. And next term, f of t which is equal to t. T is what? Which is greater than or equal to 0. So they have given f of t as t. So I am just substituting t. T into e. Here I need to tell you one thing. Okay, just concentrate on this and you will get to know that. Okay, so t into one function means f of one function, f of t function into e power means we can integrate this thing like I'm just taking here. I'm just taking u. Like wait a minute. First you need to replace it st as x because some complex terms are in the e power, right? So I'm just replacing it. So x equal to xt. So t is what? X by s. And then I'm just differentiating it. dt which is equal to dx into 1 by s, right? Yes. So just replace all these things here. And limit 0 to infinity. If I put 0 means the x will be 0. If I put infinity means the x will be infinity. So no need to change anything. So 0 to infinity x into s. This is t into e power minus x. So this thing into dx into 1 by s. 1 by s I am just putting here as constant. Okay, I am just taking out. So here you can see u and v. So I am just taking u as x by s. Right? This is the thing. So I am just taking u as x by s. And v here is e power minus x. Right? So I am just taking here. Just write like this. Okay, so I am just taking v which is equal to e power minus x. So I am just gonna differentiate this term with respect to x and integrate this term. Okay, so for integration I will go v1, v2, v3. For differentiation I am just going u dash, u double dash likewise. So u dash is what? 1 by s. And u double dash it will become 0. So omit this. v1 is what? v1 which is equal to e power minus x by minus 1. Right? Yes. Again v2 is what? E power minus x into e power minus x by minus 1 the whole square. So it will become 1. Right? So here 1 will come. Like I am writing these two terms in the first and then minus of these two terms. Like you can see here the formula is integral t into d e power t which is equal to u v1, like u into v1 u dash into v2 plus u double dash. U double dash is 0, so just omit it. So u into v1. So u into v1 I just wrote it. Again minus of, the sign will be alternatively changed. So minus u dash into v2. U dash is what? 1 by s into v2 minus of e power minus x. So here I will get only 1 square. Right? So here only 1 square. So by taking s as outside you can easily get, okay, by taking s outside you can easily get x into, okay, x into e power minus x minus of, okay, minus of the term minus e power x. Okay, so you can see here if I put infinity means these term will get 0. So 0. If I put 0 means this term will become 0. If I put 0 here means e power 1 is what? E power 0 is what? 1. Yes. So this term will become like upper limit minus lower limit. So I need to put again one minus here. So minus into minus plus 1. So I will get only 1 by s square. So this term is very important. U v1 minus u dash v2. You will see this formula in another sum also. I will tell you that. And what is gamma function? Gamma function is nothing but improper integral, which is defined by gamma is what? This term is gamma. Gamma we will denote it at like this. So gamma n, which is equal to 0 to infinity x into e power n minus 1 into e power minus x. There we saw f into e power, here x into e power x, e power minus x into dx. Gamma n means what? N minus 1 factorial. So if I say gamma 5 means it will be 4 factorial. So n is always should be positive. Okay, let's see some sum. Laplace transformation of, they have given one function here, t power n. So we need to put t power n here. This is the formula and I am just putting t power n here. You can see here I am just replacing st x kx which is equal to st. So t is what? X by s. dt is what? dx by s. So I am just replacing all these things, like t is what? X by s. So x power n by s power n, which is equal to e power minus x into dx. So I am just taking these s outside. S power n plus s power 1 means s power n plus 1, right? Okay. After that, there is only one thing, x power n into e power minus x. So what is remaining? X power n into e power minus x. I am just putting plus 1 minus 1 in the x n term. Then I can easily say this term is like x power n minus 1 into e power minus x. So x power n is what? N plus 1 is n here. So this is same like this. So I can easily write this as gamma n plus 1, right? So that's the thing here. Gamma n plus 1 by that constant. So gamma n plus 1 means what? If it is 5, gamma 5 means I can write it as 4, like n minus 1. So n minus 1 means these two will get cancelled, only n will be remaining. And you can see here they have given t power n, a function. So we have found that L of t power n is what? N factorial by s of n plus 1. This is the thing. Okay. Likewise, if they have asked L of transformation, Laplace transformation of t power 4 means 4 factorial by s power 5. If it is 4 means 4 by s power 5. Then there are some other things. If the Laplace function of e power at means 1 by s minus a. E power minus at means 1 by s plus a. If it is minus means here plus. If it is plus means here minus. These can be asked in the 1 mark questions. Just concentrate here. If it is sin at means a by s square plus a square. Cos at means s by a square plus s square. Same here. Sin means a, cos means s. Sin t means what? Here a is 1. So I am just putting 1 here. Cos means the same formula. S by a square plus 1. So we can easily say a and a as 5, a as 6. So just replace the thing here. Okay. A which is equal to 5. So a square means 25. Likewise. Then cos h into at means s into, like you can see here, at. If I had h here means I need to put negative symbol here. That's the one thing. So cos h at means s by s square minus a square. Here minus. Likewise here minus. Sin means a, cos means s in the numerator. Okay. So they have given ht. Here a is what? 1. So just substitute 1 value in the a. That's it. Okay. Next comes the properties of Laplace transform. First property is what? Linearity. Means if f of t and g of t are two functions, means L of f of t plus g of t, I can write this as in a separate form, L of the function plus L of the another function. If there occurs any constant in the f of function, means I can write this constant as outside k into L of f of t. Okay, let's see some examples here. L into, they have given some functions. You can see here this 5, 3, 6, 3, these are all constants. So I can write these things as outside. So 5 into L of t square, t cube plus 3 into L of t square. Likewise, I can write like this. After that, we have seen that L of t power n is what? Which is nothing but n factorial, right? N factorial by s power n plus 1. This is the formula. So likewise, you can see here 5 into 3 factorial by s power 4, 2 factorial by s power 3, 1 by s power 2. Here the last term, e power minus 5t. You can see here e power minus 5t is what? 1 by s plus a. So I can easily write 1 by s plus a is what? 5. So 1 by s plus 5. So this is the answer, and by doing so you can get the answer here. Normally the factorial, if it is 3 factorial means you have to start from 3 into 2 into 1, right? So likewise, just substitute all the values, you will get the answer. Simplify it. Okay, and the next thing is sine 2t cos 2t. They have given one function here, so we need to solve this. You can see here I am just writing, I know sine 2 theta, which is equal to 2 sine theta into cos theta. This is a formula. So sine 2t into cos 2t, I can write it as 2 by 2, half into 2. Like I am just multiplying 2 by 2 here. Then I am just taking this two things alone. So I am just writing sine 2 theta. Already the theta is 2 theta, 2t. So here it will come 4t, right? So this one is 4t, and then half. After that, you can see here in this thing 1 by 2 is constant, so I am just taking that outside. Half into L of sine 4t. Sine 4t means what? A by a square plus a square. So I am just substituting these things, I will get the answer. And next one is what? Shifting rule. Second property. Shifting rule means what? Like L of e power at, a function, into f of t, another function. If there is two function like e power at into f of t, means I can easily write it as f of s minus a. Okay, f of s minus a. This is the second property, shifting rule. I can shift from L to f. Okay, let's see some sum. Find the Laplace transformation of, they have given e power 2t into sine 4t minus 2 cos h 3t. So they have given this function here. So in this thing, I am just taking each term, like I am just multiplying this e power 2t in each term and L. Okay, so the function I have taken separately. So I am just taking this one as 1 and this one as 2. So you can see here e power into one function, I can easily write f of s minus a. Okay, so this is the first function, f of s minus a. So here a is what? E power at, e power 2t. So a is 2, f of s minus 2. Okay, and next thing is what? Means f of t is what? Sine 4t. They have given here the f of t is what? Sine 4t. So a by s square plus 4 square. So this is the answer for f of s. If I put f of s minus a, I need the value for f of s minus a, means just replace s as s minus a, that's the thing. So 4 by s minus 2 the whole square plus 4 square. Okay, so first thing I have found it. Second one is what? E power 2t into 2 into the cos. 2 is constant, so I'm just taking it as outside. So I just wrote this thing. Here you can see here h3t, right? If it is h3t means, like, you can write it as f of s minus 2. Okay, s minus 2, because a is 2 here, so s minus a. Here f of t is what? F of t is cos h3t. If it is cos h3t means s by a square minus a square. Here there comes minus because it is h. Okay, if there comes h means you need to put minus. So you can see here 2 into, this is f of s minus 2, right? So we need to replace s with respect to s minus 2. So s minus 2 by s minus 2 the whole square minus, here what? 4. A is 2. So a square is what? 4. Sorry. This is what? This one. 3. 3 3s are 9. So here 9 will come. Okay, this is a. And another part, cos, we need to select the number with the cos. So 9. Okay, likewise you can see here a is 2, but in sine we have 4t. So we need to select that 4 here. Likewise, we need to select 9 here, 3. Okay. So this is the answer. I'm just adding all these two things as an answer. Next thing is inverse Laplace transformation. Inverse Laplace transformation. We will see the another two properties in the next videos. I'm just going to say some problems here. Some functions and their inverse. So we know that L of 1 is 1 by s, means L inverse of 1 by s is what? 1. Like sine 0 is 0. We don't need to take 0. Sine 90 is 1. Means I can say sine inverse of 1 is what? 90 degree. Likewise here. L inverse of 1 by s is 1. Okay. So L of t is 1 by s square. We have seen that. Okay. So I can say L inverse of 1 by s square is t. So likewise we can replace the answer here. And we can replace the question in the last side. Okay. This is the thing. So there comes an extra term here. E power and n power n, t power n. So e term and t term has come, like the function into t, means n factorial by s minus a into n plus 1. Okay. And another thing here, e term into sine term. If it is come means b by s minus a the whole square plus b square. Right? We have seen that some in before cases. Okay. So this is b. Likewise here, e power at cos bt means s minus a by s minus a the whole square plus b. So this a is from e part, this b is from cos sine. Okay, if there comes h means you need to put minus here, that's it. Okay, so let's see the last sum. They have given L of t into sine at means, and they have given the answers here. We need to prove that. We know that e power I at, if there comes I means I can write it as in the complex form, like cos of at plus I into sine of at. Just write at in both sides, cos plus I into sine. So this is the thing. So I am just taking L into t, L of t into the function, this function. I am just taking this. After that, I can write this function as e power I at. Right? Yes. So here t and e part the term has come. So L of t is what? 1 by s square. So I am just taking this term. L of t is what? 1 by s square. But in term of s, I need to replace s minus a. Okay, at, sorry. So I need to replace s minus at. Here I have iat. So s minus iat. So I need to replace s as s minus iat. So 1 by s minus iat the whole square. So after that I need to conjugate multiplication. This is conjugate multiplication. Like if it is minus symbol here means I need to bring plus symbol here in the two terms. So after that you can simplify all these things, you will get this answer. So you can just separate it like this and this. This one is real part, this one is complex part, imaginary part. So I am just separating real part and imaginary part. You can get the two answers here. And the last sum, L of 1 functions, where f of t is they have given us t minus 1, t plus 1 for all t which is greater than 0, is equal to and greater than 0. So I am just taking, this is modulus, so I am just taking one negative part and one positive part. Okay, for the negative thing I am just bringing 0 to 1. Okay, for the positive thing I am just bringing 1 means greater than 1. Okay, for positive thing I am just bringing greater than 1. And you can see here f of t. So by simplifying these terms you will get minus t plus 1. So this one is like minus t plus 1 plus t plus 1, right? So the t will get cancelled, only 2 will be here. Likewise if you make this means you will get 2t. So the limit is same. After that you can see here we need to bring the formula. Formula is what? Integral 0 to infinity f of t into e power st. We know that f of t we have two things here. 2, the limit is 0 to 1. 2t, the limit is 1 to 0. So I am just taking two parts here. The first part is what? 2 into, I am just integrating it. So e power minus st by minus s. So if I put 1 means e power minus s by minus s. Minus of, if I put 0 means it will become 1. So I just got the answer as this one. Okay. And here t term into e term, like the function into e, right? So I just need to take u v. I need to differentiate this u and integrate this v. So I am just taking u which is equal to t, v which is equal to e power minus st, right? So u which is equal to t, v which is equal to u which is equal to t, v which is equal to e power minus st. So if I differentiate it means u dash is 1, u double dash is 0. So just omit these last terms. And v1 is what? Integrating this term. If I integrate it, it means it will be e power minus st by minus s. Again we are going to integrate means minus s into minus s. So minus s the whole square. The formula is what? Integral t into e power minus t into dt means the formula is u v1 minus u dash v2 plus u double dash v3, likewise it goes on. So we need to take the last two terms, so sorry, the first two terms, like 2 into, this one is constant, right? So 2 into u is what? T into this term minus 1 into this term. Okay, yes, first I need to put infinity here. If I put infinity means these two terms will get 0, right? Because e power minus infinity is 0. Next I need to put 1, right? But here you can see here this is upper limit minus lower limit. So I am just putting this minus here outside because minus of lower limit. So minus of the lower limit. Like I need to put 1 here is, so e power minus s by minus s, minus of e power minus s by s square. So I just got two terms here. So these two I need to add it. So I am just adding it. You can see here these two terms will get cancelled. E power minus s. by s. These two terms will get cancelled. This one will come, and the last two terms will be remaining this c term. So I can take 2 by s as outside, and you will get the answer 1 plus e power x. This is the answer. So this term, this one is very important. It may asked in many questions actually. And up to this video is completed, and still there are more things, or in differential equation we will complete that. I'm just searching more topics relating to the differential equation, so I have found so many things. So this video will be continued in the next video. We will see the properties there. Okay, the next two properties. Okay, thank you so much for watching this. Thanks. Bye.